All right, so welcome back. So during this lecture, so we are going to expand on our decision making process in programming. In this lecture, we'll look at how we can write logical expression using different data types. First, we'll look at integers and doubles, so essentially number types, and then we look at characters, and then we are going to look at string based comparisons that allows us to write logical expressions. Okay. Now as we have discussed previously, then we know that we are using these relational operators to make a comparison for number data type. So let's start with integers and see how we can use these relational operators in comparing numbers, right? Now when you are writing expressions that compare numbers, so we pretty much apply them as if they are arithmetic operators, just that the final result is going to be either true or false value, right? Now if I write an expression like this, 8 less than 15, so we know that 8 is less than 15, so therefore this comparison is going to give me true. Right now the good thing about this is that actually we can put them into variables, like we can say int x equals 8 and then int y equals 15, and then we can check whether x less than y. Okay, so that will also give us the same output. Okay, so therefore we can put this data into integer variables and then we can make the comparison as well. Okay, now 6 not equals to 6, we know that actually 6 is exactly equals to 6, so therefore this is going to give us false. Okay, now when comparing double values, so we can again use these relational operators. So 2.5 greater than 5.8, so we know that 2.5 is not greater than 5.8, so therefore this is going to give me false. Okay, so likewise 5.9, so less than or equals to 7.5. Here actually we are making kind of two comparisons, whether 5.9 is less than 75 or 5.9 is equals to 7.5. so we know that this one is actually less than for sure, so therefore this is going to give me true as the outcome. Okay, now let's look at one expression that has these relational operators plus arithmetic operators together. Okay, so in here then we are checking whether 2 plus 3 less than 6. Now in here then, so we have a question whether we need to evaluate this logical expression first or arithmetic expression first to make this comparison. So now when you apply operator precedence rules, so arithmetic operators have higher precedence than logical operators, these relational operators. So therefore this will be done first and then this will be done second. So therefore we are checking whether 5 less than 6. So we know that 5 is less than 6, so therefore this is going to be true. Right? So likewise in here, so when you have this one then, so before this expression we know that we need to evaluate both left hand side and the right hand side. Now when you are evaluating the left hand side, we use the operator precedence rules for the arithmetic operations. So then 5 times 4 is 20, so then 20 plus 9 is going to be 29. So we are checking whether 29 greater than or equals to 2. So that's certainly true, so therefore this is going to be true as the output. All right, so that's how we evaluate certain things based on the comparisons as well as arithmetic operations together. So always then arithmetic operations have higher precedence over relational operations. All right, okay, so now it's time for us to do a quick checkpointing question and then see if we get a good grasp of this number comparison and arithmetic operations together. Now let's talk about how we can compare characters. Right now when you're comparing characters then, so we need to base off their ASCII value to make the comparison. We know that we have integer representation of these characters in the computer memory, right? So for example, character A, uppercase A, has the ASCII value 65, right? And then the plus sign has ASCII value 42. the multiplication sign, and then the plus sign has the ASCII value 43, and so on and so forth, right? So now when we use these characters for comparisons, so we can do something like this, right? So plus greater than or equals to the multiplication. Now we know that plus is 43, multiplication is 42. So therefore, from ASCII value point of view, plus has higher ASCII value than the multiplication. So therefore, this evaluation is going to give me true, right? So likewise, if you write something like this, so character A greater than character B. So since character A starts from 65, so then we are essentially checking whether 65 greater than 66, right? Now 65 is not greater than 66, so therefore this is going to give us false as the outcome in this comparison, right? So therefore we can use these relational operators for character comparison. In addition to these relational operators, so we have this CSE type library that defines character related methods that gives us true false values also by comparing after calling these methods, right? So here are a couple of methods. So is upper and is lower methods, for example. So these methods are going to figure out whether a given character is uppercase or lowercase, right? Now I strongly recommend all of you guys to go to this particular link and then check methods available in this CSE type library for character based operations. All right, so let's see how we can use is upper method. Now if we are using the is upper method for comparisons, so then we can declare, let's say, a character variable called ch, and then suppose we are going to put a in here. Now I want to know whether ch has an uppercase character, right? So then we can check whether is upper, and then we can pass character ch into this method. So as soon as we do that, so this is going to return me either true or false values. Now ch has uppercase A, so therefore this is going to return me true, right? Now to understand how this method concept work, we can think about method as a box like this that has a name. So this one, the name of this box is upper, okay. And for this box, so we have certain inputs that we can put. Now for this one, we should be putting a character input, so therefore ch is the input that we put it in here. So when we use a ch variable in, so we are essentially passing character A to this box. Now inside this box, so we have the logic to determine whether this character is a uppercase character or not. So after doing this comparison, this box is going to give us an output based on the computation that we do inside the box. All right, so then this one has a logic for character comparison. All right, so once you do this comparison, then so this is going to return me either true or false. So since ch has uppercase A, this is going to return me true. Okay. So likewise, is lower method is very similar. So we can call is lower method and then pass ch in here. So when you pass in ch, then ch has uppercase A, so therefore this is going to return me false. All right, so therefore sometimes we can use CSE type library related methods in comparisons, in addition to using relational operators for character comparisons. All right. Here is a quick checkpointing question for us to see if we understand the character based comparisons properly. Okay. All right, now let's look at the string comparisons. So comparing strings is a little bit more involved than comparing characters and numbers. Now since string is an object, so this is actually an object, so we cannot directly use greater than, less than or equal to, greater than or equals to operators directly in comparing data stored in characters, strings. So what we have to do is instead we have to use methods associated with the string object for comparison, right? Now there's a method called compare to method. So this compare to method is going to compare two strings, and then giving us three different numbers as the output. if the two strings that we are comparing is the same, so it's going to return us 0. If the first string that we are comparing against the second one is lower than the second one, so it's going to give me a value less than 0. Usually it is -1. All right. So other hand, if the first string that we are comparing is greater than the second string, so this is going to give me a positive value. Usually it's going to be +1, right? So go ahead and actually take a look at the method definition in this library and then see how we can make this comparison, right? So now let's take a couple of examples and then see how we can apply this method in comparing strings, right? So suppose I have two strings, str1 and str2. Now I want to check whether str1 equals to str2. So I can check whether str1 compare str2, right? Now when you do that, so according to the definition, this is going to give me three numbers, 0, -1, or +1, depending on how this comparison goes, right? Now when you are doing this comparison, so we are essentially actually doing character by character comparison, right? Now we check first two characters, so they are identical. At this point then we cannot make the final decision because there are other characters to be compared. So then second character, so identical, third, fourth and fifth, so all are identical, and then no more characters to be compared. So then at this point we know that both strings have the same set of characters, and then this comparison is going to return me 0 to indicate that both strings are identical, right? So then they are the same. Okay, so now on the other hand, if I use the comparison here, str1 compare str2, so now we start comparing corresponding characters again. So h and h, so both uppercase, so therefore both are the same. Now we go ahead and compare e and I. Now when you compare e and I, we know that I has higher ASCII value than e. At this point str2 is greater than str1. So then we really don't need to compare any other thing, even though string 1 has more characters than str2. When you compare the second character, so str2 has a higher ASCII valued character in there. So therefore this is going to give me -1 because str1 at this point will figure that it's smaller than str2. So that's how pretty much this comparison works, right? So then larger than or smaller than, not really counting how many characters are in there. So but we are basically comparing each corresponding character. As soon as we find a character which is larger than or smaller than the other, so we can make that decision. All right. So let's take another example. So here then, let's say we are going to check again str1 compare str2. Now this time, so h and h, they are the same, e and e, they are the same, but str2 really does not have anything else, but str1 has more characters. That will make str1 larger than str2. So then this is going to give me +1 as the output. All right. So that's how the string comparison works. So usually when you're comparing strings, use the compare method. Do not use the two equal signs. Okay. So let's take another quick checkpointing question and then see if we got the idea behind a string comparison. All right. Okay, now that we have a good idea about how to compare numbers, characters and strings, so let's talk about one more comparison based constructs that we have in programming languages to compare multiple things and then combine the results of those multiple things, right? So suppose I want to write a program that takes the final score for a student and then determine that particular student scored A, B or C. The logic is, let's say if the score is greater than or equals to 80 and the score is less than 90. Now if we draw it in the number line, then so we have 80 here, so then including 80, so then this way, and then here we have 90, so excluding 90. But if we go this direction, so any number in this direction will result grade A for this particular student. Now, in order for us to do this comparison, then, so we have to make two comparisons. We need to make sure that student score is greater than or equals to 80, and the second point of comparison is student score is less than 90. Now, since both of these conditions needs to be true, in order for us to make that comparison, we use another set of operators called logical operators to combine the true or false values getting from these two separate comparisons. All right, then here we are checking whether if the score is greater than 80 and score is less than 90. So then the AND logic, we put it to ampersands, so that will compare two Boolean values and then give us true or false value, right? So let's say the score is 86. So now 86 greater than or equals to 80, so that is true, and then and less than or equals to 90, that is also true. So therefore this comparison is going to give me true as a final outcome. Right? So that's how pretty much we can compare the numbers and combine them using these logical operators. All right. Now, how many logical operators are out there? Then how we can write these comparisons? So in general, so we have three logical operators. So AND logic, OR logic, and NOT logic. So these logical operators can be used in combining true false value based expressions together to form a larger expression, right? So let's take a couple of more examples related to this. So now if I have a single value like true values, so when I say not true, so then not true is going to be false, right? And then not false is going to be true. And then if you have an expression like this, so 5 less than or equals to 8, so we know that this is true, and then not of that one is going to give me false. All right, so not true is going to be false. All right, so that's how we can use these operators, okay, logical operators. So let's take a few more examples to see how AND logic and OR logic work with combination of multiple logical expressions. All right, so now when we have the AND logic, then we are comparing whether multiple comparison statements are giving us true or false values, and then get the combined effect of it. All right, now here if I have a statement like this, so 5 greater than 2 and 4 less than 8, so we know that 5 greater than 2 is true, 4 less than 8 is also true. So true and true is going to give me true as the final outcome, right? Now on the other hand, so if I have 5 greater than 2, that is true, and 4 greater than 8, so we know that 4 greater than 8 is actually false. So then true and false is going to give me false, right? Now if I have another expression with 3 separate logical expressions, so first one is true, second one is true, and third one is also true, so therefore final outcome is true, right? So now in general then, so if we have this n number of comparison statements combined using AND logic, so in order for us to get the final outcome as true, all of these sub expressions has to be true. If at least one sub expression is false, so then the whole comparison is going to be false, right? So that's pretty much how the AND operator works, right? So now let's look at the OR operator and then see how the OR operator works. In the OR operator scenario, so if you have multiple of these logical expressions, so then we need to check whether one or the other, okay? So here then, so we have 5 greater than 2 or 4 greater than 8. So therefore as name implies, then either this or this. In this case both are true, so therefore final outcome is certainly going to be true. Now in the second case then we have true or false, so then we are checking whether this one or this one. Since at least one of them is true, then final outcome is going to be true, right? Now in this scenario, so 5 less than 2, that's false, 4 greater than 8, so that's also false, 11 greater than 67, that's also false. So therefore all of these sub expressions are false, so therefore the final outcome is false. Right now, then in general, so if we have n number of these logical expressions, so in order for us to get this expression true, we need to have at least one sub logical expression evaluated to true. Right? So if all sub logical expressions are false, so then the final outcome is going to be false. So in addition to having these analogic and or logic separately, so we can have the combination of and or logic as well. Right? So now it's a good time for us to have another checkpointing question and see if you understand the logical operator usage as well.